So this is the double award hire paper from 2023. Last question then, it says alkanes are compounds with a general formula, CnH2n plus 2. Give two letters where compounds are alkanes, so that's obviously an alcohol, so you're going to get rid of that straight away. Then you're looking for things where it's 2n plus 2, so it's going to be D and E. These two are alkenes. Give the name of the compound A, so that's got 3 carbons, so it's propene, and then draw the structural formula of compound E. So 3 carbons, 8 hydrogens. The diagram shows the reaction of ethene. So if you add bromine water, it turns into bromoethene. And then if you add heat in a catalyst, that's how you polymerize something. So that one's polymerization, that one's addition. And just remember to remove the double bonds and kind of straighten it out. Describe the change that we've seen in orange bromine water when molecule X is formed. It would turn colourless, and name the type of reaction taking place when a repeating unit forms. That is polymerization. Lovely bit of information now about plastic bags and paper bags, and looking at the different amounts that they have been used, essentially percentage of them used. In 2003, so looking at 2003, the consumers of the town used 1.25 million disposable bags. Use the information of the table to calculate the number of paper bags used. So 12% essentially of 1.25 million, because that's how many paper bags were used. Lovely then graph. Okay, remember I'm doing this on an iPad, and straight away I can see this bit here where it's a little bit bumpy. That's not great. You want to have like nice smooth curve through. Really nice 3 marks for just plotting some points and connecting them up. Okay, when it says draw a suitable line, please don't get lost in that. You can also draw a curve. Give the year that equals the same number of plastic and paper bags. You can see where they cross over, so there'll be a crossover point on your graph, and on mine it was 1996. Simplest ratio, use of plastic bags to paper bags in 2000 is 1:4. Givram region explains the change seen in the plastic bag usage in Wales between 2008 and 2018. Supermarkets started charging, remember we have to pay at least 5p for plastic bags now. Blank page. Bit of ionic bonding now, okay, because I've got a metal and a non-metal, okay, so I'm ionic bonding, okay, ionic bonding. So it says here, the diagram below is used to show the electronic changes that occur when sodium oxide is formed. Draw arrows to show the movement of electrons. So these 2 electrons are going to the oxygen. You'll have 2 positives because each sodium has lost an electron, and then 2 minus because this one oxygen has gained 2 electrons. Draw the dot and cross diagram of oxygen. Remember, oxygen was one of 2 that I told you to learn because they are double bonds. Okay. State the structure that is able to conduct electricity. Give a reason for your answer. Graphite has a free electron. Carbon has 3 bonds instead of 4, so it's got a free electron able to conduct electricity. Suggest which is used in a lubricant. Again, it's graphite because it's got layers that slide over each other. Give a name of another form of carbon that's used in drug delivery systems. Fullerene. You could get on with buckyball, carbon nanotubes. Lovely little bit of exothermic, endothermic questions now. So propane gas is used as a fuel. The burning of propane gas is represented by the following equation. The relative amounts of energy needed to break some of the bonds are given in the table. The total energy needed to break all the bonds in the reactants, so everything in this square is 6490. Everything in this square. Calculate the energy needed to break 1 CO bond. So first off, I worked out how much energy is in here. Okay, so I've got 2 carbon-carbon bonds, and then I've got 8 carbon to hydrogen bonds. So 4,000 is how much is in all of that. So that's now 4,000. And I've essentially got 1, 2, 3, 4, 5x, basically. Okay, so I did the whole number, take away 4,000, gave me that, and then divided by 5. So each one of them is worth 498. The energy released in all the bonds in the products are formed is 8,542. The total overall energy change for this reaction, so you're going to do reactants minus products, which should give you 2,052. Propane gas is commonly used in camping stoves. When the water is heated for 10 minutes, 22 kilojoules of energy was transferred to the water. Use the following equation to complete the temperature rise of the water. So temperature rise, there's energy transfer, and I have just realised that says kilojoules there and that says joules there. So I should have times that by 1,000. So this answer is going to be slightly different. Okay, so first off, we have to work out what it would be times by 1,000, because that says kilojoules there, that says joules. There's a lot going on here for 1 mark, but we'll just get on with it. So 4.2 times by 750 is 3150. And then we're going to divide 3150. So that would have given you 69.84. Oh, so my answer was right. Anyway, I must have maybe converted it in my head, but not written it down for you. So sorry about that. Next question then. Label a diagram again. Draw an arrow on the diagram to show activation energy. Remember, activation energy is reactance to the hump. Reactance to the hump. And then draw an arrow on the diagram to show the overall energy change. That's always the difference between the reactants and the products. So that would have been B. Blank page. Iron oxide, coke and limestone are all fed into the top of the furnace. Describe the two main functions of coke in the furnace. So it acts as a fuel, produces carbon monoxide, and is a reducing agent. So I've put 3 things for 3 marks there. Then they've given 2 different stages of what the limestone does and how it produces slag, and how it removes impurities. A group of students were asked to calculate the maximum mass of calcium oxide that could be produced from 8 grams of calcium carbonate in stage 1. Their answers were as shown. Give the name of the student who correctly calculated the mass of calcium oxide to 1 decimal place. You must show your workings. So this is reacting mass from last year. And I always do reacting mass this way. So I took the known mass, which I knew to be 8, which was calcium carbonate, and I worked out the MR of calcium carbonate. So that's 8 divided by 100. So I did known mass over known MR times by unknown MR. An unknown MR, and you can see me there working out the MR of calcium carbonate. The unknown MR then, they gave it to you there. I don't know why I worked that out when it's there. The unknown MR then is 56, times it together, and I got 4.48. So if I rounded that to 1 decimal place, Charlie would have been correct. Can you see how you've really got to know your calculations from last year and your flame tests and all that? It will come up. Give the chemical formula for calcium silicate. Okay. Which we would do top, swap, drop. They're both a charge of 2. And then iron reacts with iron reacts with oxygen to form iron oxide. Make sure that you complete the balance symbol equation. So there would have been 1 mark for doing top, swap, drop to do iron oxide. They gave you the charge that it was a 3. So when you did top, swap, drop, and then making sure that you balance it, that would have been your 2nd mark. Tough question that was. Looking at this then, this is all a sequence of reactions that we've practiced in class of nitric acid. You've got to use the information in the diagram to name the following substances. So we've got nitric acid plus magnesium makes magnesium nitrate solution and hydrogen gas. That's nice and easy. Then we've got nitric acid plus copper carbonate. Gives you 2 different things. So if you're struggling, write it out, remember? Nitric acid plus copper carbonate we'll go to copper nitrate plus water plus CO2, which will then help us answer solution A. Use the diagram to name, so you just need to name them. So it would be copper nitrate and the gas would be carbon dioxide. Then you've got zinc. Zinc is a higher metal than copper, so a bit of a tricky question. They've done reactivity as well. So then zinc is going to displace the copper from the nitrate, and you're going to end up with zinc nitrate and copper. Write the balance equation for the reaction between magnesium and nitric acid. So we've got magnesium plus nitric acid makes magnesium nitrate plus hydrogen gas. The word equation was up there. 3 marks though, that's nice to get it all into a symbol equation. And then the type of reaction that takes place between solution A and zinc, that is displacement. Take the ionic equation for the formation of the precipitate. So these two, because you can see there, if you're looking for a precipitate, it's always going to be the one that is a solid. Precipitates aren't going to be aqueous. So you've got barium plus sulfate. Add in sulfate ions, state how the student could test for barium ions, give the expected result for the positive ion. So barium, that's apple green flame, you could do a flame test. How would you test for chloride ions? Silver nitrate solution, or give a white precipitate. Lots and lots of information here to read through. Hydrogels, remember, are a smart material. So, tick the best describes the molecules that form cross-links in the hydrogels. They're unsaturated, so they contain a double bond. Give the phrase in the passage that shows that the change in hydrogels undergoes a physical change rather than a chemical change. Ability to shrink and shell. So it is a reversible, we would say, reaction. It can go back to its original. Calculate the percentage of mass of hydrogel beads when placed in water at 20 degrees. So I did change over original. Remember, this is a percentage increase. This is numeracy from last year. Change over original times by 100. So the change is 4.39 take away 0.35 divided by 0.35. So the percentage increase is that much, which would shock some people, and people won't write that. It's because they can take up over like 10,000, 1,000 times their mass in water. Write a conclusion, the effect of temperature on the diameter of hydrogel beads over time. The higher the temperature, the more the diameter increases over time. There we go, a electrolysis. Make sure straight away you write in panic, you write in oil rig, so you can get yourself all sorted out and know what's going on. And then it was a 6 marker, which was quite nice. Explain the movements of aluminium oxide and why did I just say that? Aluminium and oxygen ions inside the cell, and how the reaction at each electrode demonstrates oxidation and reductions. So first mark is ions are free to move because aluminium oxide is molten. Okay, make sure you include that whenever you're talking about electrolysis. Okay, ions travel in the opposite charged electrons because opposites attract. So aluminium goes to the cathode and oxide goes to the anode. That's where that panic anagram comes in. Reduction is the gain of electrons. Oxidation is lost. Again, that's just oil rigs. So there were 3 marks there for things that would just be knowledge that you've been taught. Then there's a half equation. And aluminium gains 3 oxygens to form aluminium. So it is a reduction reaction. And then at the anode, oxidation occurs. We've practiced doing it like this. Okay, so don't panic if you do it like that, that's fine. 2 oxide ions lose 2 electrons, which forms 2 oxygen pairs. These pair up to form oxygen molecules. Very similar to the questions that we practiced in class, that one. So yeah, it did say end of paper there. So 6 marker to finish. And then I believe it was blank page, and a lovely table of ions and a periodic table.